47. Consider moist air with absolute humidity of 0.02 kilogram moisture per kilogram dry air at 1 bar pressure. So what we have really, let's look at, let's say here we have an enclosure and here we have water vapor plus of course air, and the pressure is of course 1 atmosphere, 1 bar, and the absolute humidity is given. What is the value of absolute humidity? 0.02. By definition, this is the value of absolute humidity. This is the definition of absolute humidity. So here 8 is given as 0.02 kilogram moisture per kilogram dry air. Of course, according to this problem, it's given as 18 and this is given as 29. So there is only unknown is PA, and we can find out the value of PA, and the value of PA comes to be equal to 0.0312 bar. Calculation is shown. Okay. Now is the critical point. We have to find the due temperature of the moist air. So what will be the due temperature? What will be the due temperature? Let's say if this is at any temperature, the humidity of course will remain the same because this is a closed enclosure. If we start taking out heat at a certain temperature, which would be of course the dew point, this partial pressure, here is a partial pressure of water and partial pressure of air, and these two together is of course the total pressure. So at what temperature the partial pressure of water, which is 0.02 to 1 bar, becomes equal to the saturation pressure. And what really happens at that particular point, dew of the water starts appearing in this enclosure, right? So at that point it becomes 100% saturation. So what we have to do, so that part is easy. Now to find out the dew point, now what we do, we put this P sat is equal to PA, which is this one right here. So we say at what point, at what temperature, this PA would be equal to the saturation pressure. So from here, by calculation, we can find out the value of T. And we have shown the calculation in our detailed solution here. And we found out this value is 298.61 Kelvin. Remember, this temperature is in Kelvin. Okay. So if that is equal to approximately 25.46 degrees Celsius. So the T dew point would be equal to 25.46 degrees Celsius. What really happens? So here we have water, certain amount of water and air mixture, and the humidity is this. So we start cooling it down at 25.46 degrees Celsius. This air will become 100% saturated with this water vapor. No water vapor or air is coming in or out from the system. So that's that. So this is going to be my answer. Let's look at the psychrometric chart and see what I'm meaning. So this is my zero. This is absolute humidity. This is my 0.02. See, at any temperature, of course, the absolute humidity will remain constant. If we go to the 100% line, this is my 100% line, percent humidity. That means it becomes saturated. If we come down, you see, that becomes approximately 25 degrees Celsius. So this is my dew point. And that's my answer.